In this video, section 2.2, non-standard forms. To begin, let's take this equation. 5x plus 7 is equal to 3x minus 2. Unlike our previous equations, we have 2 instances of x. But we don't want 2 x's. We still want an equation of the form x is equal to, where this guy is the only x. So this 3x right here, we don't like it. We want it gone. How are we going to get rid of it? Subtract it. Then we'll have 3x minus 3x. That's 0. And we'll be left with negative 2 on that side. But if we want equality, we're going to have to do this same operation to the left-hand side as well. Remember the golden rule. So after the simplification and the subtraction, we get 2x plus 7 is equal to negative 2. Hey, we can solve this. We're going to use inverse reverse. This is like a problem from section 2.1. That is to say, we subtract 7 from both sides. 2x is equal to negative 9. Divide both sides by 2. X is negative 9 halves. Let's take a look at another problem. This time, we're going to have some distribution. We'll have 4 times the quantity, 2x plus 7. And we want that to be equal to 3 times 5 minus 2x. Before we start doing any subtracting or anything like that, we got to take these guys and distribute. Since we have more than one x, we must distribute. That becomes 8x plus 28. Likewise, on this side, we're going to get 15 minus 6x. Now, since we did not perform any operations, we just rewrote these expressions in equivalent forms, they're still equal to each other. We're still solving the same problem. And now our focus is on this guy. I want to add 6x to it, because then I'll have minus 6x plus 6x. They'll cancel, and I'll be left with 15 as my right-hand side. But we have to do the same thing to the left-hand side. 8x plus 6x is 14x's plus 28. And since we performed the same operation on both sides, they're equal to each other. Now, we're just going to do a little inverse reverse and solve. Subtract 28 from both sides. 4x is a negative 13. Divide both sides by 14. X is negative 13 divided by 14. And we have our solution. So I think it's important to kind of break down the method that we used here and to take a look at that. First, we distributed. Then we combined. We got down to a single x. And then finally, we did our inverse reverse. Let's take a look at another example. Let's take a look at the equation 4/5 times 3x minus 7 minus 2 is equal to 10 minus 8 times the quantity 7 plus 3x. And in keeping with our short-lived tradition here, this guy is a little spicy. But first things first, we're going to distribute. Before we do anything else, it's distribution time. So this is 4 times 3. That's 12. And it's still divided by 5x. 4 times 7 is 28. And it's still negative and still divided by 5. And we're still subtracting 2. Next, we're going to want to distribute this negative 8. It's not just 8, it's the negative 8. So 8 times 7, that's, excuse me, I have the wrong thing written down. 8 times 7, that's 56, and it's a negative 56. Now, minus 24x. Got to keep that negative sign. It's time to combine. And I'm going to go ahead and combine these two here by noting that negative 2, this 2 is 10/5. So we have 12/5 x minus 38/5 is equal to, let's see here, 10 minus 46. That's a negative 46 minus 24x. Okay. Got to get rid of that x. So we're going to add 24 to both sides. And we'll fill in the rest of the problem around it. These cancel. Our right hand side is now negative 46. Our left hand side is well, we could add these fractions, or we could just represent that value like this, because that's what it would be, right? It's whatever 12/5 plus 24 is times x. Now let's add 38/5 to both sides. And we'll divide both sides by this expression. So we'll be left with x is equal to minus 46 plus 38/5 divided by 12/5 plus 24. And if we wanted to simplify this, we could. We would sit here and we'd have to figure out how many fifths 24 is. Oh, let's see here. 24 times 5 is 0 to 120. So this becomes 120 plus 12, 132 fifths. 46 times 5 is 30, 20, 230. So this is 230 minus 38. That's 192. Negative 192 over 5. So x is negative 192 divided by 132, and they both end in 2, so we could divide them by 2 and figure out their ratio, etc. But I think we'll call it a day. That's it for section 2.2. Thanks.